I welcome Bargava Subramanian sir for this podcast. This is a kind of a podcast where I'm not just saying to myself like how to just do cybersecurity in a very short time or else how to be the best in the data science. That's not the way that you be. It's a lifelong journey of learning new things, learning new processes, breaking things and making it work. That's what it is all about. So I'm here with Bargava Subramanian sir for this session where it's not about saying myself how to be a good professional tomorrow. It's also about how to be a good human being. I saw one of his session from PyCon and I was like, damn, I need to be a professional like him. Tomorrow, I don't know how many people are going to be well versed with different technologies, but whatever you do it with a lot of passion inside you. And I think this is going to be the best thing that you might hear over a course of time. So stay tuned for the future podcasts and also stay tuned for a lot of things which is coming up. And I welcome Bargava Subramanian sir for giving me this podcast. I'm honored to have him on my show.
Thanks, Vishwas. That was extreme. I'm humbled by the way you introduced me. Thank you so much for this. And the pleasure is all mine to be here and then sharing some of my experiences with the audience.
Yeah, I just want to just rewind back in like 15 and 20 years. Just
Right.
just get to know what was going behind the mindset of Bhargav Subramanian sir. Like, did you ever imagine computer can be this potential? Like, what you saw was like, we never had an access to the cloud then. But I just want to know, did you really imagine the potential of the computer to this extent?
Uh, so frankly, no, right? So because of a couple of things. I would be lying if I tell, oh, I foresaw and I expected all of those things. So definitely no. To think that computer would be a big thing, yes, it was all being seen. I wrote my first line of code when I was 10 years old, and I've been doing programming for quite some time. It was in BASIC. We had it in school and then did a lot of things. And even before I finished 12th, I'd done a lot on Fox Pro and some of the other things. And when I joined, so that was my first introduction to databases, data and databases. And then when I joined college, got introduced to Unix and then C++. And then started learning something on my own. So interestingly, my background, the degree I did in college was mechanical engineering. And the way courses were taught way back then was as removed from computer science as possible. So access to computers was still limited. A lot of things was we probably spent like 2-3 hours in college per week in computer classes, right? All through my 4 years of engineering. But then obviously I had a personal computer. I started learning things on my own, did a lot of different projects. So it was pretty interesting. It was intense, but also interesting. Open source as a movement was just kicking up at that point of time. So you had all these magazines. I don't know if you ever know, there was this magazine called Chip Magazine. It came like 20 years back, and that's the only way where you can get a distribution of Linux. So we used to wait every 6 months for the magazine to come so that we get the access to a Linux in a drive, come home, and then hopefully not brick the system, but then install the latest version of whatever version of Linux was out there. Tried all of those things, and so that was my foray into thinking about, okay, I am very interested in computers. I'm interested in a career where I think computers can be helpful in building some of these things. Will it be as impactful to me as I'm going through experiencing it right now? I never imagined it, but that's something that I thought that it's possibly where I wanted my career to be.
Yeah, a lot of times when we think of mechanical is thought like, okay, just do some metal work, just do this thing, just do.
Yeah.
Nowadays, it's more of a CAD software. Like
Correct.
people are moving more towards like, I need to learn the software, I need to have computer skills and things like that.
Right. Right.
Amazing. Like, that I think probably open source was never thought to be this big because computers were not that feasible. Like not everybody had an access to the computer today. Like my mobile phone is a computer today. I can install any amount of Linux inside it. I can virtualize this. I can do anything. Potential of computers are so huge today. I think, yeah. But like, I want to ask you this one question: what's an algorithm to you? What's an AI algorithm to you? Because programming a brain was something that we thought of and we started this journey, but yet we have not understood the brain. But like we are trying to program something which is as close as brain. But I want your thoughts on AI algorithms today.
So I will phrase it in this way, right? So if you think about, uh, so in the book, Signal and Noise, Nate Silver talks about human beings' innate nature to predict every time. So even thousands of years ago, when human species were hunter gatherers, at that point of time, you still need to predict if a predator is going to come and then kill you, or is this a good day where you can get some hunt and you can survive all of those things, right? So how's the weather? So farmers have always been thinking about, okay, how's the weather? This is even before technology came into picture. So as human beings, we have this innate curiosity to keep predicting all the time. Now, even if you see about the way the evolution of algorithms and AI in general, so we'll split these two and then talk about it over the next few minutes. But if you think about it, the evolution itself, a lot of what initially started off, not now, 200 years back when industrial revolution started coming in, was having rules written in. So when you started having things that were repeated again and again, so rules started coming in. And then at some point 100 years back, you figure out that you can use computers to do it, where you manually input the rules that you want to create. And this is also unfortunately how computer science is still taught now, that you learn syntax, if, else, do, while. So you learn all of these loops, which all come from this paradigm that, okay, I can codify whatever is happening in terms of rules. The next level that came after that was, okay, if I can have all of these rules, if I have to set, can I make an intelligent system out of it, right? This intelligence is as of today, we don't consider that intelligence, but where at that time, at the cusp of how things were changing into automation, this is like, I have this tribal knowledge within me. Can I take this and codify into a particular way where it's useful for a set of audience? That was the genesis of something called expert system. So if you look into the papers that came in 1990s, even early 2000s, there were a lot of discussions around expert system, which is just human knowledge codified in a way that makes it easy for decision making to happen. This concept of whatever we talk about, machine learning, gradient descent, deep learning, this are all none of these are like fairly new, right? The fundamental algorithms existed for 30 years. All of these things have existed for quite a long time. The fundamental shift has been in terms of there have been two great fundamental shifts, one in terms of compute, the other in terms of access to a lot of data. So the things really started changing in mid 2000s when the compute power was able to support different kinds of models that could be built, where you now flip the stuff from moving from an expert system, which is until then that was what most of the papers were about, into something where now I have data. Can I reverse engineer the rules that generates it? So all the algorithms that are out there, just at its very core level, does this, that can I do an approximation of the underlying some function, unknown function that no one knows? Can I reverse engineer it to something as close to it as possible? That is what AI algorithms tend to do. And you can call this different ways, right? I mean, now if you take a very dystopian view of it, that, oh my God, okay, AGI, artificial general intelligence is coming, singularity is coming. I can tell you that the way the current state is, we haven't figured out that secret sauce that can help us get there. So none of all the ones that we currently have all work on one narrow specific way of doing it. We are very good at cracking certain narrow general intelligence. We're very far from doing very robust artificial general intelligence to reach singularity. The way it's currently done is that can we use data and then can we find a functional approximation that generated the data so that we can make meaningful decisions using this data. So that's how I look into AI, the usage of AI and algorithms that empower us to make these decisions.
Yeah, I met you virtually through an webinar which is called as Federated Learning and Cybersecurity. That is where I
Okay.
met you. Not
Cool.
not physically, but like I met you through a
Sure.
YouTube video. But like trust
Cool.
me, the amount of things that you talked there, I think probably it covered a lot beyond what edge computing also has today. Like federated learning was also once upon a concept, but now it's more of a jargon that time, but now it's a kind of a reality and
Right.
people are trying to implement on everything. But I want to
Yeah.
ask you this one question, like who is the most vulnerable entity to get hacked? Is it an edge device or else is it a human being?
So the okay. So the blur between human, like we're all defined through our interactions through device, right? This is like the very highly abused quote that you see here in India, that we have more phones in India than toilets, right? So we now have a situation where everyone's got a smart device, at least. Like you might, at bare minimum, you'll have a phone. A number of students and professionals like us, we also have laptops. These are not the only things, right? Now, even think about TVs. All of the TVs are Android TVs, right? All the new low-cost TVs that are coming up are all Android TVs with its own compute, and it can do a bunch of processing on its own. The new age washing machines that are coming up are all connected to the internet. So you have the proliferation of devices that get connected in are exploding, and they're a lot more than what you would think they reach us, right? So in that sense, because we all input some amount of personal data into all of these systems, which makes it extremely scary, right? So it's not, if you think about it, it's not just this. We use there are biometric systems like say Aadhaar and other things, which also have which makes us our digital footprint a lot wider than what we actually think it is possible. So the amount of damage that can happen because of a digital leak or a digital hack is far more compared to physical theft, that a thief comes into the home and breaks it in, and we are more moving towards a, some sort of digital hack. And this could be for a consumer, like even in this day and age, the amount of privacy and security that we think from a personal perspective is so low. And even for enterprises, where the amount of devices that get connected to an enterprise network is way too high, and they have very little visibility into all the devices that's out there. So in terms of the impact that a cybersecurity cyber attack can do to an individual or a company is way too high.
Yeah, I agree with you on this because sometimes it might be the dumbness of being a human that we just tend to lose that sense of like, okay, somebody might be hacking and we might do that. But I think
Correct.
machines are more intelligent than a human being to some extent, but not complete. But like, there are a lot of talks that we can give about pipelines on data science and building a new architecture and things like that. But we forget to understand building complexity, like the process which it took. And we also need to understand that there is a nightmare behind every data science pipeline. Hours and hours of hard work from different people, sleepless nights, and things like that. So I would just want to know what's the worst nightmare behind working in a data science pipeline? Like you have worked on a lot of problem statements, you have given talks. That is like you have a simple demo, you just come there, show that. But like when it comes to production system, there can be a lot which can go wrong. So what's the worst nightmare in working with a data science pipeline?
Well, so let me break this up to tell how I view the system itself, right? So one in terms of so maybe it might be good to have a bit of context around what are the different kinds of data science roles that exist, and then how does a data scientist go about doing his or her work, and who are the related adjacent areas, so that you would get a context. So we'll set the context before I answer the specific question. So if you think about data scientists, there are two major ways in which a data scientist can work on, right? One is someone who works very closely with the business. So we always talk data science as an intersection of Venn diagrams, right? So there are multiple components about knowing statistics, algorithms, computer science, business. Now there are more versions that come which adds processes and stuff around it. But let's just take this example that there's a data scientist who works very closely with the business, where the CEO comes at night 9 o'clock and tells, the sales is going down in, say, Bangalore area. Now, can you tell me what do I need to do? Like, why is this even happening? Like, because our exposure to this market is way too high, and I'm little concerned, right? This is something where somebody needs to go pull in the data, figure out and ask various questions, come up with various hypotheses, test it, and then give actionable recommendations to the business stakeholder. So this is one kind of role where your ability comes in breaking down a business problem into an analytical problem, and also come up with a bunch of hypotheses, and then keep asking questions, pull in the data, ask questions, and then present it back. This presentation typically happens in an Excel or a PowerPoint, or these days in some dashboard like Tableau. But that's one kind of role that exists. The other kind of role is more engineering centric. I am running, say, engineering at Netflix, then which would or an OTT company. Many OTT companies exist in India. So then, when a user logs in, I want to provide personalized recommendation to the user, right? And based on what the user clicked and see, I need to refresh what happens on the screen instantaneously. I cannot go back, do analysis for 2 days or 2 hours, and then come back and then present. It needs to happen instantaneously. So then your focus is more on building the engineering pipelines to support that decision which an automated algorithm takes. So the first one is more ad hoc, where you're taking more interactions. It's more a discussion or a thought process with yourself. The other one is where you're literally fighting with the machine and ensuring that everyone gets what they want at the appropriate time. So two kinds of systems, and they both have different kinds of challenges. In an engineering system, building pipelines and ensuring that the APIs don't break is an extremely important problem. Like, are you having the right process in place? Most of the time, the error happens because you don't have the right software engineering rigor in that place. Invariably, like number of times I've seen problems happen because of lack of software engineering rigor versus a wrong model being used. I would always pick that it's the problem happened because of software engineering error. The number of times that error happened has been way too high. On the other hand, the first kind of problem where I talked about, where the data scientist works closely with the business, the problem then, the major bottleneck there is in ideating, in coming up with different kinds of hypotheses. So you need to be extremely curious about data, right? So you need to be extremely curious about the domain, not so much about the algorithms. So you need to know a lot of how to think on your feet and then come with different options. So it all depends on where someone's thought processes. If someone has more way of asking questions, innately curious to ask questions, they're better off doing the first kind of problem. If someone is extremely methodical in place, then they're better off being the engineering oriented data scientists. And both are equally extremely valuable in the market. But when people learn and do data science, they invariably try to think that everything is part of the same profile. But as long as you're aware of, okay, this is what I am good at and I want to specialize on it, you're better off succeeding in your career.
That's true. That's true. Because sometimes we forget the fact that we need to get the right truth out from the data, and we fiddle around with different tools, different technologies, and we think of like, okay, is this data fine, or else is this data enough? Data is never enough. Model accuracy of 99.99% is also never enough. Sometimes when you are dealing with systems which can break out at any given point, can give you like 60% accuracy in a fraction of a second and things like that. Like, I want to ask you this one question, because you said a very valuable point about the algorithm. And I want to ask you about this big O notation, the order notation about this algorithm and things like that. You're a mechanical person where you don't really, actually, you studied mechanical, but you are more of a software person right now. But I want to ask you this one question, like, how is this making an influence in making decisions tomorrow? Like, algorithm with a big O notation stashed onto it, making a simple analysis, how is it really working to the world?
So knowing what is tractable versus what is not tractable is extremely important, right? So I mean, so now I'll tell you a very different parallel. So like how we have big O in computer science, statisticians have this concept of sample and population, right? So you would also tell that how much data do I need before I can be very the inference that I have is meaningful enough, right? So when you want to build a model or any data that algorithm that scales with the problem that you're trying to solve, all these things really matter a lot. Do most people measure it? No, right? I mean, it's all it's at some point of time it depends on where in the stack that you're in. If you're a creator of library, if you're going to create new algorithms, then you should be mindful of doing all of these things. If you're going to be answering a business question, if you're just a user of a library, then you should know like at what point does this break and what point should I go and then do something else. So now with the rise of low code, no code tools, I think there's a huge gap between people who understand fundamentals versus people who can rapidly build applications for and provide immediate answers to some business problems. So there's a trade-off that you're going to take, right? But knowing like how long will a model take or any algorithm will take to converge, will it converge itself or not? What's the right way in which you have to write code? All of these things still matter a lot. It's not about just only about, so it's about running time complexity, space complexity, because you need to know that if I'm going to do it with 1 million data points versus 1 billion data points, what happens? Do I need to you brought this point about edge computing, right? We've done a fair share of work around it, where you need to know like what can I keep it on the edge, how much can I put it onto the cloud. Just remember that as you move data through, as you increase the workload on your edge device, the chance that the edge device will fail also goes up, right? Because it also has this finite amount of how much it can handle. It's very sensitive to heat and all the other fluctuation that's happening. The more pressure you put, it could fail, and then your entire system can be compromised because of doing something like that. So so taking algorithm as an individual piece is probably not the way to think about it. Have a holistic thinking about, okay, these are the various things that comes in. I need to know how often the data comes in, where it's going and sitting. What do I need to do now versus what can I do it later? Or what can I use the warehouse? And which is the most optimal way of doing it? All of those design decision choice makes a big difference. So in that sense, having a very good understanding of system design is extremely important these days.
Yeah, that's true. Because we forget the complexity behind it, and we go behind what industry is doing it, and we sometimes give the same approach that, okay, I learned a case study from this company, they are doing similar thing, let's just put in the same, let's just rig up the same architecture, let's just rig up the same workloads and things like that. But like, there's a gap between what program asks for and what we literally know. Like, if you take an interview, like probably you're working on something known as a React, but the interview might land up asking you something like, code me a website using vanilla JS, something
Yeah,
like that.
true.
Something like that. But I want to know, like, you're from a non-coding background, like from your bachelor's, but you started coding at the age of 10 and you were good at it, and you built your own startup and you started working on data science stuff that not most of the people might just move into, since most of the time when they go with the mindset of doing something with a lot of hardware, they lose their traction for that software. So I just want to know, is engineering background on learning software required in order to understand the basic concepts of data science or deep learning? What is it all about? Like, how to build a startup by learning what to be done? That's my question.
So two different things, right? I think being a builder and running a startup are very different things. Okay, so I mean there are enough similarities, but I mean there are enough differences around it to be very different, right? So let me answer the first question that if you're a builder, you're an engineer. You don't need a degree to call yourself an engineer. I firmly believe in that many great builders, and then that's what definition of I define engineer as someone who makes things possible, right? Who's a compulsive builder to make it happen. So having a formal education in this day and age where education is so democratized, it's having requiring a formal education is a joke. So you can just go and then find whatever you're interested in, right? So you had a question like what was I thinking when I was 15, 20 or 15 to 20 years back, right? So obviously a lot of things that I know now I had no idea. I mean, these some of these fields I hadn't even heard of all of these things before, right? Like back then, I, all I did was okay, learned typewriting shorthand so that if things don't work out, there is a job, a government job that would be awaiting all of us, right? So, but then new sector, computer IT opened up, and there's a lot more jobs that came up. When you start doing, being fundamentally curious, and then trying to work your, so this the analogy I try to give is peeling the onion. So start with knowing what is happening right now. So do it so that you have your job today and you can get it done. But then as you peel the onion, it's layer after layer. You go down and you understand everything around that particular field. So building depth is extremely important. The fundamental thing that I would say is build like a T-shaped stuff. So have enough depth and then know enough of various things so that you're potent and deadly in that particular field. But it's extremely important to know the basics, because if you're going to build something on someone else's tool, and especially given today's condition where everything is going to be done on cloud, where it's not your infrastructure, you need to know the limitations that it comes from doing something. The advantages it comes, obviously it provides tons of advantages, but then it also has its own set of disadvantages. You need to know that, okay, what am I optimizing for right now versus what are the things that could hit me pretty badly later on, right? So all those things happen only if you can have a strong background in all of these things, and to do that you need to have I would say that be reading, see what's happening in your field all the time, talk to people, whatever works for you, right? I mean, I would call this build your own community, find your own community and be around them, and be innately curious knowing about it.
Do you remember your first project delivered as an owner of a startup, or as the founder of the startup? Like,
Yeah.
what was it all about? Like, like I think probably 5 years before, I didn't see this is the amount of, not 5 years, I think 7 years before, I didn't know what was data science at all, because nobody cared whether YouTube gave out the auto suggested videos or things like that. Because nowadays it's like more of like, okay, you're doing this, you're doing that, so I'll take your data and I'll personalize it for you. And like, what is it all about? Like, how was your involvement in those days and how did it start? That's my question, because sometimes we forget, because we have all tools in the cloud. Cloud has stashed with tools like Azure
True.
has logic apps, Databricks, everything is stashed. AWS has the same, GCP has the same. I just want to know, what was that process for you to learn, deliver the products and things like that. And also you can also say the present day's barrier that we have in delivering an effective projects in the production environment.
Okay, so when I start, so okay, good question. So this is about when I started initially. I had I came from a number of years spending in extremely large enterprises, right? Many of say Fortune 100 companies, working and then leading data science over there. Learned things about, so one of the advantages working in extremely large organizations is that you get access to all latest cutting edge uh, tools, right? So because every vendor keeps trying to sell into these companies, and then you would get to see what is happening, and then you quickly understand the gap, telling that okay, as a large company, you get access to a number of these tools, but then also the world has a number of small and medium sized businesses who have little to no idea either about these tools or don't have the access to these tools because they are prohibitively expensive for a number of reasons. That was the trigger point where I realized that okay, there is a huge market which is still largely untapped, and getting enterprise grade AI ML to the small and medium sized businesses is quite a possibility, right? So, even 5 years back, the amount of thing that you could do for a small and medium sized business was quite low compared to the advances that we have now, which enables us to do a lot more for small and medium sized businesses. So that was a trigger which made me get into. And by that time, I was already mentoring a number of startups, and I was consistently seeing the same pattern of okay, how do I get these data, how do I build these models, what do I need to tell my customers? And this is like okay, you have like tons of people doing this in enterprise, but no one does this for small companies. That made me think that okay, there is an opportunity to come and then build SaaS products in this particular space. My first company was building recommendation system for a set of. So at that time, we had Netflix of the world, Amazons of the world, doing phenomenally good recommendation systems, right, for their consumers, for their customers. But then if you're a mid-tier or the long tail brand or company, your access to the similar kind of technologies was relatively hard, right? Either you need to get to hire data scientists or know how to do it. Now, it's not just data scientists who were needed. So algorithms by themselves at that time was fairly well known. What was missing was the data engineering piece. Like, how do you get the data? How do you process them in real time? How do you deliver them in a way that makes the engineering system effective in parts in connection with the entire app ecosystem, right? So that's where we saw the gap, and that's what I set out to build. We had a bunch of customers around the world which used that particular technology. So it was mostly technology, a SaaS product which helped anyone personalize. So the differentiator that we brought in was a lot of companies were trying to focus on product recommendation. So if you're an e-commerce company, then doing product recommendation was the most told one. But then content, like if you're watching videos, what videos to watch. If you're reading an article, what other articles are similar to this, was not so well understood, right? So that was the problem that we built, and then we got some customers. So that, to identify one technologies that you're using, and then seeing that okay, is there a fit for this outside wherever I'm currently using? Maybe there are places where the possibility is to use only within that particular organization, but sometimes you can take that and then build a tool with the knowledge that you have for a new customer base which has been extremely underserved. And that is one way in which you can do a startup, right? Like, because you know the problem really well, and there's a segment which has been traditionally underserved. So that's the genesis of how the startup itself began. Right. So the two ways in which you can build a data science company, right? You can build a standard software, or you can like a SaaS company, or you could just do AI consulting. And both in this day and age, both are equally lucrative, because knowing, understanding data and then building systems around it custom for a particular company versus building something that many customers can use, both has its own set of advantages. So the biggest challenge in doing all of these things in this day and age uh, is generally access to data, right? Because the algorithms are well known. There are really a lot of good libraries that exist, but understanding what problem to solve, and then how do you get access to the data so that you can build some meaningful out of the box, off the shelf algorithms which a customer can use. So tailoring these two things is typically currently a very hard challenge.
Yeah, but like, I just want to ask you this one question, because where do you see algorithms influence in the AGI today? Like, every algorithm makes a decision, has some model built, gets deployed on a production environment, so-called on cloud, and sometimes on premises and things like that. These are still a jargons to a lot of engineers. Like, people like, okay, SaaS product. What is SaaS? They'll be somehow or the other using SaaS, but probably people don't know that. But I want to know, what's the influence of algorithm in building AGI? Like, everything is accessing data today. Like, my Google Assistant has a lot of access to the data. Like, it knows it's there in the living room. It knows my Wi-Fi. Yeah, it knows my Wi-Fi. It's Vishwas and it should get connected there. Like, that
Right.
precise. I want to know, what's the influence of algorithm in building AGI for tomorrow? Because what we are doing is, we are using the same old linear regression algorithms that we used to use, but we are modeling it in a different form factor itself. Like, it's on edge, it's on phone, it's on laptops, it's on everywhere. So I want to know, what's the influence of AGI bought from the algorithms that we are today? That's my question.
So I don't know. I don't think I'm well suited to answer this question. I think researchers have been working for this much longer and have a much better point of view. But just seeing the space, right? I think the algorithm that can help us get to an AGI, we still haven't figured it out. So if you ask me, is it because lack of data, or is it lack of the right algorithm? I think it's because we don't know what the right algorithm is to use it. We have tons of data about various different things. Even going from learning from one task to moving to the other task itself has been a huge challenge these days, right? So it's just getting solved. Like, multitask learning itself is like a term that's been getting popular only in the last 2-3 years. So how can you learn from one task and then use that to apply on another task? Or how can you learn two tasks simultaneously? So those are some of the things that multitask learning helps you figure it out. And these themselves are fairly new right now. I don't think we are anywhere near AGI yet. So we haven't figured out the algorithm that can get us right there. Pretty much all, at least in the industry, a lot of what is currently happening are still very narrow AI. So you know what problem you're trying to solve. You go find the data, label the data, train the model, and then ensure that it does that particular task really well. That's all the focus is right now.
Thank you, sir. Thank you so much for giving a lot of insights. Because trust me, because I'm a really biggest fresher to this world of data science. And there are a lot of freshers like me who have no clue about what it is. Like, if somebody says Databricks, data lake, we still, oh my God, what is happening in the industry? And it's all simple jargons that we are just afraid of, but we are not giving ourselves that push to understand something beyond what that complex world is also all about. I think you covered a lot beyond what software architecture was, what algorithm was. I think, thank you so much for giving me such a wonderful podcast. It's an honor to have you on my podcast once again. Like, if you can give me 10 podcasts, I'm ready to have it.
You're welcome. It was really good being here. Thanks, Vishwas.
Thank you so much, sir. Thank you so much. It was nice talking to you. I hope
Same here.
everybody listens to this completely and get to know what is industry.
Thank you so much.